So for our example, we want to do some regressions, and we have Borks I'm going to treat as the response variable in these regressions, the dependent variable, the variable that we're trying to predict on the basis of the dog's attributes, which are its size and its fur. So here is one description of the data. This is ignoring Borks, just looking at how many of the dogs are in each size and fur category. We know this is how I generated the data on purpose. So, but it's worth tabulating this just to illustrate that most of the big dogs are fluffy and most of the small ones are scruffy, right? So that's going to become relevant later when we think about what we're actually doing with our models. Here is a histogram of Borks. It appears to be bimodal. We will see why in a minute, but that's also useful information if I was actually going to fit this model. And then this one tells me the average mean number of Borks in each of the 4 categories of dogs. And so the most seem to happen for the small fluffy dogs, and then the big fluffy dogs and the scruffy dogs are Borking less than that. I'm going to begin by plotting this information. Basically, we have 2 binary variables and 1 numeric variable, and I've plotted the numeric variable on the y-axis. The small dogs are all plotted on the left here and the big dogs on the right. But the horizontal spacing is just to spread the dots out so we can see them. These dogs are all small. There's no difference between one on the left and one on the right within this group. So that's called jitter. When you plot, you can use jitter to spread some points out over limited space in a scatter plot, just to make them more visible. But it's important to remember that your jitter is not actual quantitative information. It's just a visual tool. And I've color coded them by fluffy or scruffy. So left is small, right is big, blue is fluffy, red is scruffy, and then higher up on the scale is Borks. So I made this example really obvious so that we could see exactly what was going on. Normally, of course, in any real world research application, you wouldn't have your groups so obviously separate like this. They would overlap. But I thought it made it easier to see visually what's going on. So we have these clusters of points for each of the 4 types of dogs. So I'm going to move that over here for a second and walk you through the plot. The first thing I did is I ran these 3 lines of code in order to set up the colors that I want to use in the plotting. I just want to plot all of the points for the fluffy dogs in blue and the scruffy dogs in red. So I created a color vector that I just called color. That's an arbitrary name. That was all missing values for the length of the number of rows in the data set. I could have just written 200 here, would have been fine. Or I could have retrieved the first dimension of the data set to notice that it had 200 rows. For whatever reason, I decided to do length of the fur vector extracted from the data frame. All of those are just ways of getting the number 200 in case I forgot that there were 200 rows. So now I have 200 missing values, and I'm going to replace all the ones where the dog's fur is fluffy to blue, and I'm going to replace all the ones where the dog's fur is scruffy with the string value red. So after running that, color is just blue and red depending on the fur. The reason I keep moving stuff around in part is that some parts of my window are occluded by the Zoom preview of your faces. And so I know this part of the screen is just empty for you now, but it's not for me. This line plots the points. You can see those points here. The first argument is the x position of the points, and I just took size equals big will give me true for the big dogs and false for the small dogs. Convert it to numeric so the trues become 1s and the falses become 0s. And then I add some jitter. I let it just pick a default amount of jitter, but that results in some points just above and below 1 for the big dogs and above and below 0 for the small dogs. So you can't see it on the x-axis because 1 and 0 don't have any meaning here, but this is 1 and this is 0. The second argument is the y coordinate, which is just the number of borks for each dog. No jitter there. Those are numbers that vary from like 10 to 70, so I didn't need any. It's easy to distinguish the points in that dimension. This is the color argument, and I supplied to that argument the color vector that I had already prepared, which is just the string red and the string blue over and over again, corresponding to the fur type of each dog. The next argument is axis type, which I set to none because I didn't want to plot, -1 and 0 and 1. Like this would be like around -0.5 or whatever, and this would be 0 and 0.5 and 1 and 1.5 because of the way I distributed the points in horizontal space using this argument, but I didn't want to actually show that because instead I'm going to replace those with just the labels small and big. xlab, that's the label of the x-axis. I just set it to an empty string. I didn't want it to print the name of the variable down here for whatever reason. I set the limits of the x-axis to -0.5 to 1.5 because it just seemed like that would position the points nicely kind of in the middle of the space that I wanted to plot. And then the y limits from 0 to 70 because I wanted it to start at 0 instead of the bottom of the data. And 70 seems like a good ceiling for the number of borks that we have. Actually, the maximum is exactly 70. That's the end of the plotting function. I'll just actually show you what it looks like at that point. This is what it looks like at that point. So all I have left to add is the words that label the x-axis and the legend that I put in the upper right-hand corner.
Is this how you normally do your plot, Sarah? Because
yeah,
okay, that's good to know because I usually am using like xlab and I'm trying to space it out inside there, and it seems like it's so much cleaner to just do this extra line that adds to the plot.
Oh yeah, I often do multiple lines to add things to the plot. Yeah, I mean, sometimes you can just use the xlab argument exactly within the plot command, but for complex stuff, sometimes it's nice to have separate arguments. So mtext is one useful one that just places text in the margin of the plot. And I wanted the text to be the words small and big. And 1 here, that argument is which side of the plot. So 1 is the bottom, 2 would be the left, 3 the top, and 4 the right-hand side. So 1 means bottom. 0.5 is what line, like 0 would be right at the axis here, and they count upwards as they go away from the plot. And then at is the position of the text in terms of the units of the plotting on that axis. So 0 and 1 will be the positions like here and here. So when I run that line, I get those 2 words appear in the margin. And then the last thing is this legend function, which plots that box in the upper right-hand corner. 0.9 is the horizontal position. So it's going to start the box right around here because that big is at 1. So I just wanted it to be around there. And 73 is near the very top of the plotting region. That's the y coordinate of where the upper left corner of the legend is going to be. These are the words that are going to be in the legend, fluffy and scruffy. The colors of those words, the colors of the points next to those words to illustrate which is which. So blue is going to be the color of fluffy and red the color of scruffy. They're in the same order. And then this is just the plotting point type, which is the default one that I kept as the default when I ran the plot command before.
Can I ask a question?
Mm-hmm.
So one thing that I actually struggle with a lot is like placing my legends around the plot, and like doing that in the correct way, as well as like with the significance bars too. Because I've never really understood like how to know based on the dimensions of your plot where to place things. So for like, say like the value 0.9, you chose that value because the groups are 0 to 1, right? Or is that based on like another rule that you chose it?
No, that's it. Like I previously I knew that I had plotted these small points at 0 and the big points at 1. That's how I defined the x-axis.
Okay.
And I knew that I thought the legend would look good around here.
Okay.
So, I probably tried 1 first and thought that that seemed too far to the right, and maybe I tried 0.8 and thought that it seemed too far to the left.
Mm-hmm.
so I settled on 0.9. You know, I might have tried a few things and just picked a position that I thought looked good to me.
Okay, that makes sense. And then the 73 um is the top of it, right? So like where
Yep.
it ends. Okay, cool. Okay, that makes sense. Thank you.
There's lots of different ways of doing this too. So I can show you maybe another time some plots that I've done where there's like a legend that's outside of the plotting area and stuff like that.
That'd
And
be
this is just
super.
a real simple one for this example. So this is like pretty, like, I make plots that are much more complicated than this. I know this is really, it's not that complicated, right? Besides the color stuff, it's just 3 lines of code. And I wanted to be able to whip it together for this example, which is part of also why like the y-axis is still dat $borks. Maybe if this was for a real like presentation or something, I would have changed it to just borks and maybe capitalize the words that were relevant. Like if I was really giving a conference talk on this important topic.